Hello class, and welcome to another simple science video, and this is a very much requested topic, or rather a very long chapter in our IGCSE revision series, that is organic chemistry. And in this video I hope to introduce organic chemistry and the main basic concepts that will allow you to describe every group of organic compounds that you will learn in this very long chapter. And this chapter is going to be quite difficult for those who are weak at memorizing things, but if you are good at memorizing things, then great. Okay, so this chapter or topic will basically barely involve any stoichiometry or calculations. It's mainly going to be hard textbook stuff. Okay, so let's just introduce the background of organic chemistry as its own. So if I were to characterize organic chemistry and base it around a single element, it would be carbon. And I'm going to use living organisms to introduce organic chemistry. So in other videos or textbooks, they tend to use crude oil, but I tend to associate things that are closer to us. So in this video I use living organisms to introduce organic chemistry. So living organisms are made primarily of carbon. So most compounds, or you will find a prevalent number of compounds inside us and other living beings, and they will be made of carbon, such as amino acids, which basically make up protein. Okay, so carbon compounds as a result are very versatile, and this is because the carbon atom has 4 available bonding electrons in its valence outer shell, so it can form 4 different types of bonds and 4 different types of configurations. So therefore it can form a massive amount of configurations to form very different carbon compounds. So this is why they are very versatile. So carbon can form bonds with other atoms such as hydrogen, oxygen, and nitrogen. So these 3 compounds are very common to form bonds with carbon. But additionally, carbon can also form bonds with other carbon atoms to form very long chains or branch chains of carbon atoms. Okay, so the fact that carbon is able to bond with different atoms as well as carbon itself allows living beings to have such huge variety. Okay, so now we talk about a very important concept in organic chemistry, and that is the CH group. So in all living beings there will always be carbon compounds which contain the CH bond. And what's great about the CH bond is that it will help us separate between compounds which are not organic and compounds which are organic. So we characterize it as the CH group, which is basically a group containing the carbon atom, the hydrogen atom, and the 2 electrons which form a covalent bond between them. That's all it is. And as I said, it helps us separate separates compounds that are organic and not organic, and it will help us define organic chemistry. So organic chemistry is basically the study of compounds which contain this group. So therefore, organic compounds are basically compounds which contain the CH group. Okay, cool. Now we go to learning about how to describe organic compounds. And a first step to describing organic compounds is having a symbolic way in which we can describe them. So we commonly use formulae to describe organic compounds. So there are 3 main different types of formulae. There are actually 4, but we'll talk about the 4th one, which is the general formula under homologous series. Okay, so 3 main formulae to describe any organic compound. So the first one is the molecular formula, and then you have the structural formula, and then you have the displayed formula. And I will talk into detail about each formula. So the first is the molecular formula. You probably have seen this before. So a molecular formula is basically a formula that will display the exact number of atoms of each element in the compound. So for example, we will use the example on the left, which is ethane, which is a compound which contains 2 carbon atoms and 6 hydrogen atoms bonded in this covalent compound. So therefore, the molecular formula is simply C2H6, where 2 is the number of carbon atoms and 6 is the number of hydrogen atoms. Now let's look at the structure formula, which is basically the same as the molecular formula. However, it splits all carbon atoms in the formula into its separate positions so that all the surrounding atoms around each carbon atom are put separately. So in other words, for this example, the first carbon atom is represented as C, and the first 3 hydrogen atoms which surround it are H3. So we have the formula as CH3 followed by CH3 again, which represent the second carbon atom surrounded by the second set of hydrogen atoms. Okay, so the total or the whole structural formula which describes ethane is CH3CH3. Okay, now let's look at the easiest formula, which is the display formula, which is basically the structural formula, but it shows all of the bonds, all of the covalent bonds, and the arrangements of the bonds surrounding each of the carbon atoms. Okay, so those are basically the 3 main formula you can use to describe any organic compound. So let's look at a concept, as I mentioned briefly, the homologous series. Okay, so in organic chemistry, in our IGCSE organic chemistry, you will learn about 4 main groups of organic compounds. The first being the alkanes family, second being the alkenes family, third being the alcohols family, and the carboxylic acids. There may be reactions between members of each of these families, but we will talk about that in a much later video. Okay, so homologous series. Right. Each of the organic groups of compounds are known as a homologous series. So the alkanes family is known as a homologous series. So all alkanes they belong to a homologous series called the alkanes. So all alkenes belong to a homologous series groups of alkenes, and so on. So homologous series is basically a fancy way of saying a group of organic compounds. And what the great thing is for each homologous series they share similar characteristics. So all members of a homologous series will have the same functional group, which are basically responsible for the chemical properties. Don't worry about this. All 3 of these bullet pointed I will describe in detail in the next couple of slides. Okay, so they will have the same functional group, which will determine their chemical properties. And since they have the same functional groups, they will have similar chemical properties, or they will react the same way to other atoms or on its own. Next, they will show a gradual change in physical properties, which in other words means is that members in a homologous series will have very, very similar physical properties, but they will only differ by the number of carbon atoms in its chain. And of course, these examples I will mention in very much detail when I talk about or make a video about each homologous series in much more detail later on. And they will have the same general formula, which is basically a formula used to symbolically describe any organic compound within a homologous series. So let's look at what I mean by them having the same functional group. A functional group is basically a group of atoms which are responsible for all chemical reactions involved in the members of a homologous series. So for example, in the alkanes homologous series, the CH group is responsible for all chemical reactions. In the alkenes, this carbon-carbon double bond group is responsible for all reactions in the alkenes. In the alcohols group, the OH bond connected to the carbon bond will be responsible for all chemical reactions for alcohols. And in carboxylic acid groups, the COOH or the COH O will be responsible for all chemical reactions involving carboxylic acids. Okay, so as a result, they are responsible for the chemical properties which make each homologous series different from each other. So when I talk about them showing a gradual change in physical properties, or they're showing similar physical properties, but they depend on the number of carbon atoms in the chain, what I mean is that the physical properties of the members of the homologous series will depend on the number of carbon atoms within the chain. So for example, let's use the boiling point of the members of a homologous series as an example. So as you can see, for alkanes, as you increase the number of carbon atoms in the chain, the boiling point of each compound will increase very predictably in a straight line. So we call this a gradual change in physical properties, and these changes, as you can see, will apply for alkenes, alcohols, and carboxylic acids. So in all organic compounds, the physical properties will be very, very predictable based on its homologous series and its number of carbons in its chain. Okay, so the last concept that I talked briefly in homologous series is the general formula. The general formula is basically a formula involving a variable n, which is able to describe or name a molecular formula for all members of the homologous series. So for example, looking at the alkane group, the general formula is CnH2n plus 2. So in this case, we have ethane. So if you plug in the N as 2, you end up with the molecule correctly as C2H6. So based on the number N, which most of the time will be the number of carbon atoms, you will basically have the molecular formula to all members of the homologous series. So this is applicable to alkenes, alcohols, and carboxylic acids. Okay, so I hope you find this video useful. Please, if you have any questions, just shoot them down in the comment section, and I hope you can subscribe to my channel, like my videos, watch my other videos to help you with your revision. And if there's any feedback you can give me, that would be awesome, and I wish you the best in your revision. Thank you.